And so this is, I'm recording for my test. Share screen. What that's doing now. I don't know what that is, but whatever. Okay, so the witch and the rutabaga and watercress problem. So what probability she planted rutabagas in the bed? I did the formula, probability WR equals probability of W plus probability of R minus probability of W and R. And then I plugged in the numbers for that right here. I don't know what that thing is. And I got the probability of R is 0.594, 59.4. Probability that she didn't plant watercress rutabagas in the bed. Use the formula for that. Plugged in the 0.76. And then 24% 0.24. Watercress but not rutabagas. That formula. And plugged in the numbers once again from the top. And 0.166 or 16.6. Probability that she planted in the bed, given that she planted watercress there, would be probability of watercress rutabaga over probability of watercress, 0.13 over 0.04, 0.5, 54.9. And then for E, I got the same thing because the formula ended up giving me 0.138 and 0.304 at the end, which is 54.9 again. I think that's right, but I don't know if they should be the same number. Okay, question 2. Here we go. The tabby cat one. So, given I did all the probabilities here, sleeping 68, awake 32. When she's awake and petting 13, and then I don't have to say all those, but if the cat requests more petting, when petted, the probability that she was asleep was probability of S and P. So yeah, you plug in that formula, and then you put all the numbers in of the petting and asleep, or the probability of wanting to be pet and being asleep, and the probability that she is asleep down low. Up top, and then you do it down low, but you have to add the probability of being pet, wanting to be pet and awake, and the probability of being awake as well. And I plug the number is, and it is 0.84547, which is 85.47. If the cat requests a game of fetch when petted, the probability that she wasn't asleep. So the probability equals her being awake and wanting the game of fetch. That's what G is, by the way. It's fetch. It's not F. So the probability of wanting to play the game of fetch and being awake, and with the probability of being awake up top, and you do it down low, but you add it to the probability of game when sleep and probability of being asleep. Plug in the numbers that they gave us up here. And then I got 0.1536 over 0.3304 equals 0.4649. 46.49%. All right. Question 3. Yep. In the first part of this question, I'm asking you to give, so the background story that I did is suppose you have a group of 18 people, out of which 10 are men, 8 are women. Sorry, someone's texting me. So, yeah, 18 times 17 times 16 all the way down to 1, so that equals, and yeah, I don't know that number, how to say it, but there it is. Probability 18, 18 times everything down to 1, 18 minus 8 times everything down to 1, so 10, and then that number, 18 to the 5th, so 18 times so 5 times, and then 18, 11 equals 18 times itself all the way down, over 11 times itself all the way down, times 18 minus 11 times itself, which is 10. Actually, no, it's 7. I'm stupid. 18, yeah. 18 times itself, 11, 7, and then 3,000, 31,824. It's not 3,000, it's a little bigger than that. There's the other one. Yeah, this is it. So for that one, F. Yeah, I plugged in the numbers, did the math for the 10 repeated multiplied down to 1 all the way through. Multiplied by 8 at the end, got 1,680. For G, this one took me like a whole day to do. It's pretty hard, but you do that formula, divide it. 10 to that power, 4 to that power, 6 to that power, divided by 4 and 6, and equals, yeah, there, that's what that equals. And then 210. And then H, yeah, all of that. I don't really even know how to say all that, but it is, yeah, you can just see that. That's just a lot of words. There's not much explanation to do. I just followed the formula. 4. 13. No, A, B, C, D. Yeah. So consider the following table. Yeah. I have some more written down on 4 on my paper, actually. Yeah, this is the same paper. But so using probability distribution right there, probably x equals 1. And to replace the question mark in it, I added everything on the bottom row together and then equaled 1. And then with the question mark there, like that, or subtract 179 from 1. So we could replace the question mark with 0.21. B, give 2 numbers that you could replace the question mark with that would guarantee this table would not be a probability distribution for different reasons. Identify the reasons for each of those numbers. So I got negative 0.21 and 0.30. Negative 0.21 is because the probability of any event can't be negative in probability distribution, so it would make it not. And then also any other value by the sides, 0.21 just won't satisfy the same probability distribution. So that's why 0.30 works. I got pins and needles on my foot. C, calculate the expected value for the probability distribution you obtained in A. So yeah, plug in everything from A, put it into the formula, plug in all the numbers from up top, 1.16. Probability professor wants to make a different, yeah. To replace the value of 4 to make a gain loss to keep all the values the same, what should she change the 4 to? So the value replaced is 4. I'm going to replace a 4 with a 0 in the formula. and then do the whole math out for that. And it comes out to you can place value of 4 with 1.8 or negative 1.8 minus 1.8, sorry. And I did that just because I thought 0 would be the easiest number to replace with. They're already telling me it's replaced. And yeah, that's it. How do I? Oh, that's how I do it. Thank you. Stop recording.